I am Dr. R.J. Golden Renjith Nimal. Today I am going to handle the topic in theory of machines. So what is meant by theory of machines? So theory of machines is a branch of science which deals with the study of relative motion between the various parts of a machine and the forces which acts on them. So this is the definition of theory of machines, and it is broadly classified into four types. One is the dynamics, kinematics, kinetics and statics. So what is meant by dynamics? So dynamics is a branch of theory of machines which deals with the forces and their effects while acting upon the machine parts in motion. So this is a definition for dynamics. And what is meant by kinematics? So it deals with the study of the relative motion between the various parts of a machine, the motion without considering the force causing the motion. So that is the difference between the dynamics and the kinematics. Then what is meant by kinetics? Kinetics it deals with the study of inertia forces which arrives from the combined effect of mass and motion into consideration. So example, weight of the body. So and this inertia force is fully depending upon the inertia force. And what is meant by inertia? So inertia is a property of matter by virtue of which body cannot move of itself nor change the motion impacted to it. And this force and motion is governed by three laws of motion, that is the Newton's laws of motion. And the first law is otherwise called as the law of inertia. So what is the first law of Newton? It states that every body continues its state of rest or of uniform motion along a straight line unless it is acted upon by some external force. And come for the statics. In statics, it deals with the study of forces and their effects while the machine parts are at rest. So the machine part, the mass of the parts are assumed to be negligible. So come for the machines. What is meant by machine? So machine is a device which receives some energy and transforms it to some useful work. So example is dynamo. Dynamo, which is used in the bicycle, can be taken as a machine as it converts the mechanical energy into electrical energy which powers the headlamp of bicycle. And we can say another example as machine tools. So machine tools in workshops such as lathe, shaper, planer, etc. are machines as they convert the electrical energy supplied to them into some useful work, that is turning of rod, tapper turning, thread cutting, etc. Then come for the topic structure. What is meant by structure? So structure is a assemblage of number of resistant bodies having no relative motion between them and mean for carrying load and having a straining action. So this constitute the structure and its members. So example is machine frame, bridges, buildings, roof trusses, etc. So what is meant by mechanism? So mechanism, when one of the link of a kinematic chain is fixed, then the chain is known as the mechanism. If different link of the same chain is made to be fixed, then it is called as a different mechanism. So it is classified into different types. Two types, that is the simple mechanism and the compound mechanism. So simple mechanism means a mechanism with four links is called as a simple mechanism. The example is slider crank mechanism. Then compound mechanism. Compound mechanism means mechanism more than four links, that is called as a compound mechanism. Example is the typewriter, etc. And what is meant by kinematic link? So each part of a machine which moves relative to some other part is called as an kinematic link. So kinematic link is otherwise called as element. So a link may consist of several parts which are rigidly fashioned together so that they do not move relative to another part. So we can say many examples from reciprocating steam engine, and it is classified into three types. One is the rigid link, flexible link, and the fluid link. So what is meant by rigid link? So rigid link means it does not undergo any deformation while transmitting the motion. So example is connecting rod, crank pin, spindle in lathe. And the second thing is flexible link. Flexible link means it is a link which partially deformed in a manner not to affect the transmission of motion. Example, belt, ropes, chains, springs, bands are deformed considerably, which transmitting the motion, but deformation has no effect on the transmission of motion. And the third one is the fluid link. Fluid link means when motion is transmitted by means of a fluid, it is called as a fluid link. So fluid link example is fluids used in hydraulic machines like hydraulic jack, hydraulic cranes, etc. Then come for the kinematic pairs. So what is meant by kinematic pair? A pair is a join of two elements that permits relative motion. So when any two elements are connected in such a way that relative motion is completely or successfully constrained, means then it is called as a kinematic pair. So this kinematic pair is classified in three ways. One is the nature of relative motion between the link. The second one is the nature of contact between the links. Third one is the nature of mechanical arrangement. The first thing is nature of contact. Nature of contact. So contact means it is classified into two types. One is the lower pair and another one is the higher pair. And the second by means of relative motion. So it is classified into six types. One is the sliding pair, turning pair, cylindrical pair, rolling pair, spherical pair, helical pair. And the third type, it is classified into two types. One is the closed pair and unclosed pair. Then what is meant by this sliding pair? So sliding pair is the classification of the relative motion. So sliding pair means when two elements have sliding motion relative to each other, then it is called as a sliding. So example is piston cylinder, tailstock on the lathe bed. Then turning pair. Turning pair means when two elements are connected such a way that one element revolves around the another. So it forms the turning pair. It is otherwise called as hinged pair. As I already told, hinged pair is and turning pair is similar. And the example is the shaft with the collars at both ends fitted with in the circular hole, and cycle wheel turning over the axles. So these are some of the examples. Then cylindrical pair is almost equal to the rolling pair. And spherical pair, what is meant by spherical pair? In the spherical pair, one link is constrained to swivel in or about other fixed point. So attachment of car mirror is a best example for the thing. Then lower pair. What is meant by lower pair? So lower pair and higher pair are the classification based on the contacts. So lower pair means if the pair in motion has surface contact between two elements, it is called as a lower pair. So nut and bolt, bolt and socket joint, shaft rotating in a bearing, then piston reciprocating in a cylinder are the examples. Then higher pair. Higher pair means if a pair in motion has a line or point contact between the two elements, so it is called as an higher pair. So belt, rope, chain, drives, and gears, cam and follower, ball bearings are the examples for the higher pair. Come for the kinematic chain. So what is known by kinematic chain? A kinematic chain is defined as a combination of kinematic pair joined in such a way that the relative motion between the links or elements are completely or successfully constrained. So this is a kinematic chain, and there are two equations for finding the kinematic chain or not. So L is equal to 2p minus 4, J is equal to 3 by 2 into L minus 2. So where L is the number of links, P is the number of pairs, and J is the number of joins. And come for the constrained motion. There are three types of constrained motions are there. One is completely constrained motion, uncompletely constrained motion, and successfully constrained motion. And the next one is the inversions of mechanism. So inversions of mechanism means the method of obtaining a different mechanism by fixing different links in a kinematic chain is called as an inversions of mechanism. So example, 4-bar chain. So it is the most fundamental and simplest kinematic chain, and it consists of 4 links and 4 turning pairs. So example is crank, connecting rod, lever, and the frame. So the 4-bar chain is basically based on the Greshov's law. So Greshov's law states that the sum of the shortest and the longest link cannot be greater than the sum of the remaining 2 link lengths when there is a continuous relative motion between the members. So this is the Greshov's law, and this kinematic chain has 4 links. Already I said crank is the shortest link in the kinematic chain. Then connecting rod, it is otherwise called as coupler, and it is located opposite to the coupler, that is connecting rod, and opposite to the fixed link. And the third one is the lever, it is otherwise called as a rocker and the follower. This has partial rotation or oscillation motion. We can simply call it as levers. And the fourth one is the frame. Frame is the fixed link is called as the frame. So this is the 4-bar chain, and the second one is the single slider crank chain. Single slider crank chain, we have one slider, one crank and the connecting rod, and the third one is a double slider crank chain. So the double slider crank chain, we have 2 sliders, so hence it is called as a double slider crank chain. And come for the inversions, we have 3 inversions for 4-bar chain. One, there are applications based on the inversions. The first one is the beam engine, second one is the coupled locomotive wheels, and for the third inversion we have 2 applications. One is the Watt's indicator, and the next one is the pantograph. Similarly, for the inversion single slider crank chain, we have 4 inversions. One is the first inversion, second inversion, third inversion, and fourth inversion. And the first inversion, we have 2 applications. One is the reciprocating engine and reciprocating compressor. The second inversion application is Whitworth quick return mechanism and rotary engine. Then the third inversion applications are crank and slaughter lever mechanism and oscillating cylinder engine. Then the fourth inversions application is bull engine and the hand pump. So these are all the important inversions of single slider crank chain, and this is a very important mechanism, crank and slaughter lever mechanism and the Whitworth quick return mechanism, which is used in the working of shaper. And the last inversion of the kinematic chain is the double slider crank chain. Double slider crank chain has 3 inversions. One is the first inversion, second inversion, and third inversion, and each application is elliptical trammel, Scotch yoke mechanism, and Oldham's coupling. So these are all the important inversions of the the double slider crankchain. Apart from this, we have Geneva mechanism, Ackermann steering, bicycle, and rear wheel sprocket mechanism, and the foot operated air pump mechanisms. And these are all some of the important mechanisms which we are following. Thank you.